So just continuing this, what values of k will give no solutions, unique solutions, and many solutions to this group of equations or system of equations? So the first thing we're going to do is put it into augmented matrix form. So the top line becomes 1, 1k, 2, 3, 4, 2k, and 2, 3, minus 1, 1. And we're going to do what we normally do. We're going to try to reduce this to row echelon form. So row 2 is going to be row 2 minus 3 lots of row 1. So we're not touching that top line at all. So we can write that in. So 3 minus 3 lots of this is 0. 4 minus 3 lots of this is 1. 2 minus 3 lots of this is 2 minus 3k. And k minus 3 lots of this is k minus 6. And if we look at the bottom row or the third row, R3 is going to be R3 minus 2 lots of R1. So it's falling out fairly quickly. So 2 minus 2 lots of this is 0. 3 minus 2 lots of this is 1. Minus 1 minus 2 lots of that is minus 1 minus 2k. And 1 minus 2 lots of 2 is minus 3. So that's our new matrix. And the next thing we're going to try to do is get rid of this 0. So we'll write it up here. We're not going to touch the top line. And we're not really going to touch this second line. 2 minus 3k, k minus 6. And this last line, what are we going to do? We're just going to minus R3 minus R2. So we've kept it fairly simple. 0 minus 0 gives us 0. 1 minus 1 gives us 0. Now this, just be a bit careful here. We're going to have R3 minus this. So minus 1 minus 2k minus 2 minus 3k. So what we're going to get is 1 minus 2 is minus 1. Minus 2k plus 3k is k. And the last one, it's going to be minus 3 minus this. So minus 3 minus k minus 6. That's going to give us minus 3 minus minus 6 is going to be 3 minus k. And if we look back at here, I obviously stuffed up, didn't I? Minus 1 minus 2 should be minus 3 plus k. Don't you hate it? Yeah. Okay. So there's our matrix. Is it in a nice form for us? Yes, that's in row echelon form. So I'll write it. I'll rewrite it so we've got some space to look at the three different situations. So we've got 1, 1, k, 2, 0, 1, 2 minus 3k, k minus 6, 0, 0, minus 3 plus k, 3 minus k here. Okay, so if we have a unique solution, a unique solution means that this is going to be a number, a non-zero number. I should say a non-zero number. So as long as a unique solution, what that implies is that minus 3 plus k does not equal 0. In other words, k does not equal 3. So as long as k doesn't equal 3, we have a unique solution. So what happens if k equals 3? If k equals 3, then this is going to become this. 1, 1, 3, 2, 0, 1, minus 7, minus 3. Here we're going to get 0, 0, 0, 0. Now, there's two things that can happen. If k equals 3, we've got this 0, 0 line. Because it's all zeros here and a 0 here, that's fine. This is going to give, if k equals 0, because of this, infinite solutions. Infinite solutions. Basically, because there's two equations in three unknowns. So there's loads and loads of different solutions. And it depends on this 0. If this 0 had been a 6, in that case, there would have been no solutions, because that means that this just doesn't make sense. 0 times x plus 0 times y plus 0 times z gives you some value, 6. We can't find an x, y, and z that will do that. So that if it was a 6, no solutions. Okay, so there are the three things that can happen: one solution, no solutions, or an infinite number of solutions. Thanks.